In this video, I'm going to solve this non-homogeneous differential equation using the method of undetermined coefficients. And the differential equation is y double prime minus 4y prime plus 3y is equal to t square minus 2t plus 3. Please note that the right side is a polynomial, okay? To solve a non-homogeneous differential equation, we break it down into two differential equations. One is the homogeneous part, the other is the non-homogeneous part. We know how to solve the homogeneous part with constant coefficients. Once we find that solution, we find the non-homogeneous solution, or we rather assume some solution that's supposed to be or likely to be a solution to the non-homogeneous differential equation. And then once we find that, we combine the homogeneous part and non-homogeneous part to come up with the general solution. So let me just write it in mathematical equation, what I just said. Your solution or general solution to this differential equation is going to be of this format. Y of t is equal to y sub h of t, which is the homogeneous part of the solution, plus y sub p of t, which is some particular solution to the non-homogeneous differential equation. So let's go ahead and find the homogeneous solution, which is very easy. The corresponding homogeneous equation is y double prime minus 4y prime plus 3y is equal to 0. So this is the homogeneous one. Now our assumption is that the solution is going to be of this format, e to the power rt, and I'm going to go ahead and write it out. So if I take the double derivative, I'm going to have r square, right? Then minus 4 times r plus 3, and all of these terms will be multiplied by e to the power rt. So I'm going to factor it out, e to the power rt, and that is going to give me equal to 0. Now e to the power rt, that cannot be equal to 0 because it's an exponential function. Now with this, we are multiplying this factor. Since the first one, this term is not 0, this must have to be equal to 0. So if we solve it, it's going to be r square minus 4r plus 3 is equal to 0. That I could factor out into, let's just do it, r square minus r minus 3r plus 3 is equal to 0. If I factor out r from the first two terms, I get r times r minus 1. From the second two, if I factor out negative 3, I'm going to get r minus 1 is equal to 0. So r minus 1 times r minus 3 is equal to 0. So my two solutions, r1 is equal to 1 and r2 is equal to 3. So my general solution for the homogeneous part, y sub h of t, is going to be equal to c1 y1. Actually, I'm just going to write down the solution, c1 e to the power t plus c2 e to the power 3t, where c1 is some constant and c2 is some other constant. Now that's my homogeneous part of the solution. Now let's go ahead and do the non-homogeneous part. So the non-homogeneous part is this one, when I have the polynomial on the right hand side, and just by looking at it, we kind of would make an assumption that the non-homogeneous differential equation that we have here, it will have a solution or particular solution of this format. Y sub p is equal to a times t square plus b times t plus c, where a, b, and c are constants, and our goal is to find these constants. Okay, that kind of comes from the name, as you can guess, method of undetermined coefficients. So these are the undetermined coefficients. So now if y sub p is this, then y sub p prime is gonna be 2at plus b, right? I'm just taking the first derivative, and the second derivative, y sub p double prime, is gonna be just 2 times a. Now I'm gonna put these terms into this equation and then try to rearrange the terms and then go from there. Once I enter those values into this equation, this is what I get after simplification. Now let's look at this equation and kind of compare few things. So on the right hand side you have a polynomial, and on the left hand side you have a polynomial. So the coefficients on both sides must be equal, okay, for the corresponding terms. So t square has a coefficient of 1 here, and t square has a coefficient of 3a here. So it must be the case that 3a is equal to 1, and that's going to give you a is equal to 1/3. So that's one value. Now by comparing the coefficients of t on both sides, we get, on the left hand side we have negative 8a plus 3b, and on the right hand side we have negative 2. And by comparing the the constant terms, we get 2a, so this is going to be it, 2a minus 4b plus 3c is equal to 3. Now if we simplify these terms and do the algebra, we get b is equal to 2/9 and c is equal to 29/27. That gives me my particular solution. Y sub p is equal to at square. So at square is 1/3 times t square plus b times t. B is 2/9 times t plus c. C is nothing but 29/27. 29/27. Now your final solution, or the general solution for this given non-homogeneous differential equation, is gonna be y of t is equal to y sub h of t, the homogeneous part, plus y sub p, the particular solution, added. Okay, so y of t is gonna be c1 e to the power t plus c2 e to the power 3t, okay, plus the non-homogeneous part y sub p, which we just found 1/3 t square, or t square over 3 plus 2t/9 plus 29/27. So this is the solution to this non-homogeneous differential equation. I hope that this discussion was helpful. Thank you very much.